All right, these are your units on your notes on density. This is a particularly important part of the unit because we're going to introduce not only what density is, but the type of unit density is, which is a derived unit. So please make sure that you title and date your notes to keep them organized. So, types of units, there are two. Okay, there are simple units, and then there are derived units. So the simple unit is like grams for mass, or liters for volume, meters for distance, seconds for time. So all of those units, they're only one type of unit. So those mass, volume, those are all properties that matter sometimes has. So, but when you only have one type of unit there, like grams or liters or meters, things are kind of easy, right? Well, now, a derived unit is when we have a mathematical combination of simple units. Okay, so when we look at something like speed, speed is actually meters per second. Okay, so you'd have meters divided by the number of seconds. So you have two different units there. You have a distance unit divided by a time unit. Pressure, grams per square centimeter. Okay, we'll be talking a lot more about pressure later, but we may not necessarily be using those, the grams per square centimeter, but we'll be using other units. And then density, which its unit is in grams per milliliter. Now, in this video, we're going to talk about how to calculate density, but also understanding what density is. So density is the mass of a substance, little typo right there, mass of a substance per given volume of that substance. Okay, so it's usually determined in a lab by dividing the mass of that substance, whatever it is, say a liquid, mass of liquid, divided by the volume of liquid that that sample is taking up. So for example, a very important liquid that we're going to be dealing with in class is water. Now water takes up, or water has a density of 1 gram per milliliter, meaning that every milliliter of water is actually also 1 gram of water. So that comes in handy later on when we do some dimensional analysis, when we look at converting, say, mass to volume and dealing with water. So knowing that they're equal is a good thing. Okay, so I definitely write that down in your notes. All right, so using density. So we can use density to find mass, okay, by multiplying the volume of a substance by the density of that substance. Okay, now obviously density would have to be something that's given, and the volume would have to be given. So pretty much here I have three variables, m, v, and d, and you're solving for one of them, but I have to give you the other two. So if you're solving for volume, if you're solving for mass, then you would need the volume and the density. Okay, if you wanted the density, okay, like in the last slide, down here, density, I would need the mass and the volume, and I would divide the mass by the volume. And then if I was to find the volume, I would need to divide the mass by the density, or V equals m over d. Now, if you're thinking, well, okay, so there's three different equations. They're all based on the same thing. Is there a way to keep them organized? And the answer is yes. I actually do have a shortcut for you. And I'm sure some of you have seen this before, but we'll go ahead and refresh our memory. You get this little circle, right? And you're going to see this a lot this year because a lot of different properties of matter have this relationship that density has with mass and volume. Okay, so for density, we'll put here, we'll put mass up here, and we'll put volume down there. Now, really simple is how to use this is you draw this on your piece of paper. Now, obviously, I can't do this because you can't see my hands. But if whatever of these three variables I want to find, I cover up. So, for example, if I was to cover up, okay, if I was to cover up mass, let's go ahead and just erase mass, right? If I was to cover up the mass, then I would have density times volume, which is just like the equation that I gave you earlier, right? And then if I wanted to find volume, I would cover up volume with my thumb or finger, whatever, when I have this drawn on my paper. And then I see mass, and then a line, and then density. So I have mass over density to find volume, right? And then lastly, if I cover up density, then I see mass divided by volume is density. Okay, so that's a nice little shortcut for determining, which equation do I use. Whatever, if you have this drawn on your paper, all you have to do is just cover whatever variable you're trying to solve for, cover it up. Now, what's important, and we'll get to this when we do the equations, what's important is that all of your units match up. And what I mean by that is if my mass is in grams and my volume is in, say, milliliters, right? My density must be in grams per milliliter, okay? Which means, like, for example, I couldn't just cover things up and plug in the numbers if my units won't match up. So, for example, let's say my volume wasn't, uh, say my volume was in liters, and my mass was in grams and my density was in grams per milliliter. I could not just, kind of plug and chug in my numbers and do a simple mathematical function, because liters, or I guess you can highlight that, liters and milliliters are not the same thing. They're the same type of unit. They're both volume units, but because they're not the same type of unit, we can't just cancel them out. So that's where we're going to get into some type of conversion later on, where you'll be able to convert to make sure all your units will cancel out and all your units will be on the same page or talk to each other, however you want to put it. All right? So what I want to do here is do some example problems. Okay? All right, so a student finds that 23.50 milliliters of a certain liquid masses at 35.062 grams. What is the density of that liquid? So if I was to write out my little circle thing, right? Here it is. And I know density, volume, mass. Okay, I'm trying to solve for density, so I'm going to cover up density, and I have mass over volume. So density is equal to mass over volume. In that case, my unit, now the thing is I didn't specifically ask for a type of unit for density, so this unit in density is going to be a mass unit over a volume unit, and whatever I happen to have given in the problem is what my answer is going to be. So my mass is going to be 35.062 grams divided by 23.50 milliliters. Now what I mean by I don't have a specific unit, okay, when I do this final answer, I'm going to end up with a unit of grams per milliliter. Okay, nothing canceled out, so that's just what I end up with. Now, if I said, oh, I need the answer in kilograms per liter, then you'll have to solve the division problem and then do some conversion, but we'll get to the conversion next week. Okay, so here I'm going to have an answer in grams per milliliter. So when I type it in my calculator, I'm going to end up with 1.492. Okay, and that would be my final answer for this particular problem. The density of that liquid would be 1.492 grams per milliliter. Okay. My next problem, I have a density given to me. The density of gold is 19.32 grams per cubic centimeter. Now it should be cubic centimeter, so it should look like this. I don't know why that's blue, but 3. Okay. How much space, so when I say how much space, I'm looking for volume, would a 52.45 gram nugget of gold take up? So I want to know how much space would a gram of nugget take up if it's 52.45 grams and it is 19.32 grams per cubic centimeter as a density. So here I have my trusty circle, right? Density, volume, mass. I'm trying to solve for volume. So I'm going to need a mass over a density. So my volume is equal to mass over density, right? Well, mass is going to be 52.45 grams, and my density is 19.32 grams per cubic centimeter. Now, if you take a look at this, I have grams on top, of a division problem and I have grams on bottom of a division problem, which means I am actually able to cancel out the grams, and my final answer is going to be in cubic centimeters. So when I do the problem, 52.45 divided by 19.32, I end up with 2.7, looks like 2.71, we'll go and go, we'll go one more, 715 milliliters, or in this case, not, excuse me, cubic centimeters. So that's the volume of that gold nugget that weighs, or that has a mass of 52.45 grams. All right, we'll do one more. So what is the mass of an aluminum can that takes up 0.15 cubic centimeters? The density of aluminum is 2.70 grams per cubic centimeter. All right, so let's take a look at what we have. We have a mass. Oh, no, sorry, we don't have a mass. We're looking for the mass. All right, and this means this cubic centimeter, that's a volume unit, and then we have a density unit. So that means we have density and we have volume. We're looking for mass. So again, if I was to draw my little circle here, density, volume, mass, I'm trying to find mass. So I cancel that out, and I end up with density times volume. So we'll go ahead and do that. We'll go mass is equal to density times volume, which is equal to 2.70 grams per cubic centimeter, right, times our volume, which is 0.51 cubic centimeters. Now, when we have this value right here, okay, hopefully everybody can understand that I can rewrite this like this, 2.70 grams per essentially one cubic centimeter, right? That's the same, these two things right here, they're the same thing. Okay, the reason why I'm writing that is because when I multiply, let me get rid of this little line I just drew right there for a second. When I multiply by 0.51 centimeters cubed, what that does is that allows me to cancel out the cubic centimeter value. So this cubic centimeter unit actually does cancel out, and all I'm left with is grams. So my final answer in this case is going to be a multiplication of 2.70 times 0.51. My final answer is 1.38, okay? And the answer is in grams. So what would the mass of an aluminum can be that took up 0.51 cubic centimeters? Well, the density of a substance, okay, I'm not sure if I mentioned this, but the density of a substance never changes. So the density of an aluminum brick, the density of an aluminum can, the density of an aluminum beam is 2.7 grams per cubic centimeter. Okay, so because of that, and the fact that it doesn't change, if I had a piece of aluminum that took up that much space, it would have 1.38 grams of mass. All right. Now you're going to have some problems on the form that follows, so just make sure you answer those. And if you have any questions, by all means, ask in class.